Hello and welcome to this tutorial. This video explains how to easily create a Candera Studio asset file using a cluster image from Photoshop. Let's first create a new empty solution by double-clicking on the Empty Solutions template. Next, save your solution by clicking the Save icon in the toolbar and choosing a suitable location. Enter Quick Start Solution as the file name and click the Save button. A solution file with the extension .scs will now be created. After doing so, click on Import, then click on Smart Importer and select from Local File. From the menu, choose the file named Car Cluster. The Smart Importer dialog will open, showing a preview of the image and a list of layers. You can now expand the layer tree and select the Gauge Left item. The system will try to detect the control automatically. When the gauge control is detected, click on Apply. The image will now be converted into a usable gauge control. Let's now go to the Appearance tab and check the layer mappings. The needle image was already detected. Now, set the background image and adjust the pivot point to the center. In the Basic Properties tab, rename Gauge Left to Speed Gauge. Set the maximum input value to 240 and the rotation max value to 225. Then, in the layer tree, expand the speed gauge and select layer 000. You can now apply a text value control from the Available Controls section. Rename this control to Speed Value and set the format text to %03D so the speed shows in 3 digits. Repeat the same steps for Gauge Right. Rename Gauge Right to RPM Gauge and set the maximum input value to 8000 and the rotation max value to 225. Then, in the layer tree, expand the speed gauge and select layer 0000. You can now apply a text value control from the Available Controls section. Rename its text control to RPM value and set the format text to %04D to display 4 digits. Finally, the next step is to convert the top status indicators into actual telltale controls. To do so, expand the Status Top section under Telltales and select the airbag icon. The system detects it as a telltale control, so apply it to the layer. The on-state and off-state images are already set correctly, so the telltale is fully configured. Repeat the same steps for brake, engine, indicator left, open doors, and indicator right. In the bottom status bar, select the 78.32 km layer and apply a text control, since it was not yet detected by the AI. In the Basic Properties tab, set the name to odometer. As a next step, select the petrol control and configure it as a progress bar, then click Apply to complete the configuration. You can leave the default properties as they are. Then, select the temperature control and configure it as a progress bar as well. Also here, the basic properties are already set correctly. The Photoshop file also contains layers for car status info. An incoming call in the center section. Final step is to now create separate scenes for these variations. For that, right-click in the Scene section and select Clone Scene. Rename the new scene to Car Status. Then, create another clone and rename it to Incoming Call. You can now select the Car Status scene, expand the layer tree, uncheck the car layer, and enable the Car Status layer. Next, select the Incoming Call scene, expand the layer tree, uncheck the car layer, and enable the Incoming Call layer. Now the preview panel will show the updated scene accordingly. After verifying all scenes, click OK to import them into Scene Composer. In the Solution Explorer, you will now see 3 template scenes: Car Cluster, Car Status, and Incoming Call. You will also see the imported bitmap resources arranged in a tree structure. These template scenes cannot be edited directly. To create editable scenes, right-click on a template and select Add Scene from Template. The Add New Scene 2D dialog allows you to configure different settings. In the lower section, you can select the template scene on which the new scene will be based. In this case, select Car Cluster and click OK. Repeat the same steps to create the car status scene and incoming call scene. Now, the car cluster scene is created from the template and can be edited. Double-click on the car cluster scene to open it. You will see the visual appearance of the scene in the scene editor. In the scene tree panel, you can view all controls, objects, and nodes arranged in a hierarchical structure. Controls can be easily identified by their blue icon. To improve the visual appearance of the speed value text, select the speed value node in the scene tree. In the Properties editor, go to the Layout section and change the horizontal size from automatic to a fixed value. Then, in the Controls section, set the text alignment to center and set the Format Text property to %D. This ensures the value is displayed clearly and centered. Apply the same changes to the RPM value control. To do so, select RPM value, set the horizontal size to fixed, align the text to center, and set the format text to %D. The updates will be reflected immediately in the scene editor. After completing the car cluster scene, the next step is to configure the display using the Render Targets panel. The display already has a default render target. Drag and drop the car cluster scene camera into this render target and enable it using the checkbox. You can remove and use scenes like Scene 2D and Scene 3D using the shortcut menu in the Solution Explorer. If a warning dialog appears, confirm by clicking OK. Finally, click the play button to run the cluster HMI in the CGI player. You can interact with the logic while Scene Composer handles all background processes like generating the asset, starting the player, and loading the asset. Starting the CGI player opens the display where you can see the simulation along with the GUI window for additional settings. On the left side, all available scenes are listed. To view your scene, enable the scene named Car Cluster. Select the Car Cluster scene and open the Controls tab, which shows all controls in the scene. To simulate a value, select a control such as the speed gauge and enable the simulation checkbox for its value. To simulate a telltale like the airbag, select the airbag control and enable the simulation checkbox for its state. Similarly, enable simulation for other telltales like engine, open doors, and brake. To start the simulation, click the clapperboard icon in the menu bar. This will generate values based on the settings in the Value Generator tab. The Value Generator allows you to simulate changes and control values without writing any code. In this example, values change in a sine wave pattern. Now you will see the speed gauge needle animating and the telltales will blink based on their simulated values. To add logic without the need of coding, CGI Studio provides behaviors. Behaviors are small, reusable functions that can easily modify nodes in the scene. These behaviors communicate using events, allowing them to share data without direct connections. In this case, behaviors are used to forward the gauge values to the text displays at the center of the gauges. To add the required behavior to the RPM gauge, open the car cluster scene and select the RPM gauge in the scene tree. Scroll down in the toolbox and find the forward value behavior under Value Processing. Once you have found the right one, drag and drop the behavior onto the RPM gauge. Once you have added it, select the forward value behavior to view its properties. To link it, click the Browse button next to Target Node. In the dialog box, locate the RPM value control under the RPM gauge, select it, and click OK. Now, repeat the same steps for the speed gauge. Add a forward value behavior to the speed gauge and set its target node to the speed value control. The forward value behavior is now configured to send the gauge values to the corresponding text controls. If the speed gauge still shows 0, refresh the Scene Editor panel. After that, the values will be correctly displayed in the text controls. Next, the video will explain multi-language support, which allows you to switch between languages and units easily. In this example, it is used to switch between the distance units miles and kilometers. To enable this, create cultures by clicking the Culture Solution Options button in the menu bar. Add a new culture and select English. Then create another one and select German. You can also search by typing GER to find German quickly. Click OK when finished. Now expand the scene tree and select the odometer node. In the Properties panel, click the magnifying glass icon next to the text property to open the language table. First, select the master culture and add a default text such as 78.321 kilometers. You can also add a translation hint for clarity. Next, switch to English and enter 78.321 miles. Then, switch to German and enter 78.321 kilometers. Click OK to save. Please note that in this tutorial the value itself is not adapted from miles to kilometers and vice versa. When you switch between cultures, the displayed text updates automatically. Now test this in the simulation. Save your solution, select Generate and Play and click the Play button. In the CGI player, enable the car cluster scene. Go to the Controls tab, select the RPM gauge and enable simulation for its value. Do the same for the speed gauge. Start the simulation by clicking the clapperboard icon. The gauge needles will move and the values will update in real time. To adjust simulation values, go to the Value Generator tab. Set the maximum value to 8,000 for RPM and 240 for speed. Next, the video will introduce the state machine, which allows you to create application logic without coding. Then the default global state machine from the Solution Explorer. As you can see, it contains an initial state, a state, and a transition. Now we need 2 more states, so add 2 more states to the state machine. Now rename the added states according to the scene names, one as car cluster and the other one as car status. The final one should be named incoming call. Now we need to create 3 transitions. To do so, connect car cluster to car status by dragging the transition icon from the toolbar, and then adjust it for better visibility. Then repeat the same steps to connect car status to incoming call and incoming call back to car cluster. Also adjust those transitions afterwards. Add on entry and on exit behavior to the 3 states. Click the plus button to add the entry. Now select transition request, then change request type to activate. The identifier should be your car cluster scene. Now add an exit behavior. To do so, click on the plus button under On Exit. Then select Transition Request. Set the request type to Deactivate and set the identifier to Car Cluster Scene. Now repeat the same process for the car status state and the incoming call state. Set the identifiers to car status scene and incoming call scene respectively. Now click on Transition and select Event Condition Filter and set it to Clicked. To trigger this transition, set the right indicator telltale in the scene as the sender. When you click on it, the scene will change. Repeat this process for the remaining transitions. Set the sender as the respective right indicators of each scene. Now create 3 more transitions in the reverse direction. First, connect car status to car cluster. Then repeat the same process to connect incoming call to car status and finally car cluster to incoming call. To trigger this transition, set the left indicator telltale in the scene as the sender. When clicked, the scene will change. Then repeat the same process for the remaining transitions, assigning the sender as the corresponding left indicator in each scene. When the indicators are clicked, the transition should be triggered. To do this, add handle control state to both the right and left indicators in the car cluster scene. Repeat the same process for the car status scene and the incoming call scene. Finally, click the Generate and Play buttons. Now you can see that when you click on the indicator telltales, the scenes change. This completes the setup of scene transitions using the state machine. This is the end of this tutorial video. Thank you very much for watching.